Hey guys, today we're looking at the second lesson for the probability unit that we're covering in Algebra 2, and it's covering theoretical probability. Most of this stuff is pretty straightforward, and it's stuff that you've actually been dealing with intuitively for many years now. These questions are stuff that you're asked early on in your math career. But we're going to start off with probability's definition here, which is that probability is the measure of how likely an event is to occur. Like the odds of winning the lottery is like a probability. The set of all possible outcomes is called the sample space. The important thing. If you listed all the possible outcomes, that would be the sample space. Then, for equally likely outcomes, the theoretical probability of an event, P of E, is the ratio of the number of favorable outcomes to the total number of outcomes possible. All right, so the key words here is it's a ratio of favorable outcomes to total outcomes. So you always have to consider what is the favorable outcome and how many choices can I make for the favorable outcome, and then for the total number of outcomes. So let's look at the first example. A jar contains 32 red marbles and 28 blue marbles. Right? So what is the probability that a randomly selected marble is red? The favorable outcomes is the red ones, and there are 32 of those. And the total outcomes is not just the red marbles, but the red and the blue, which would be 28 plus 32, which is 60. And you can give your answer as just a reduced fraction or a decimal if the decimal terminates. And if you want to round and it says to round, then you can go ahead and do that. The 32 over 60 is 8 over 15. This is approximately 0.53 repeating. So it's like a 53% chance that this happens, which makes sense since there's only a little bit more red than blue, right? Number 2, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? Well, all you have to do is think, how many vowels are there over how many total letters are there? So there's 1 vowel, 2 vowels, 3, 4, 5 over the total number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so there you have it. Next up, a day in the month of January is randomly selected. What is the probability of selecting a prime number? So, something we need to consider is prime numbers. Do you know what the definition of a prime number is? Prime numbers are numbers that are only divisible by 1 and themselves. So, like 6 is not prime because you can make it with 1 times 6 and 2 times 3. You can never make it with more than just 1 times the number, it's not prime. So, a day in the month of January is selected. Well, January has 31 days, right? And so the prime numbers going up to 31 would be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. 1 is not considered prime, and it's certain definitions don't make sense why it's not considered prime, but just it isn't. So just take my word for it. So how many prime numbers are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers. 4, 8, 9, 10, 11. Yeah. 11 out of 31. So 11 of those days in January are prime. Number 4, 2 dice are rolled. What is the probability that the sum of the 2 dice is at least 9? All right, something I want to write out here. I'm going to make a chart. All right, so here's the chart. This is 2 dice, dice number 1 and dice number 2. And there are, if you want to read this chart, this would be an example of, maybe you roll a 2 and a 6. This would be a 1 and a 3. This would be a 1 and a 4. This would be like a 3 and a 1. So we're going to make this chart. I'm just putting dots here to indicate, this would be like a 6 and a 6. So what I'm pointing out here is that there are 36 different possibilities of the 2 dice being rolled. You could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5. With the second dice could roll a 1, so it'd be like a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, right? So 2 dice are rolled. What is the probability that the sum is at least 9? This chart can really help us with that. So the first, if you're looking on this first row or the third row here, a 3 and a 6 would add up to be 9, right? It just so happens that if you look at the diagonal of this one here, so this would be a 4 and a 5, that also adds to be 9. If you take 5 and 4, that also adds to be 9. And then 6 and 3, that also adds to be 9. And then anything more than 9 would be 6 and 4, 5 and 5, 5 and 6, 6 and 4 again, and 6 and 5. So we count all the ones that sum up to be at least 9, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of the 36. Which reduces into 5 over 18. Yeah. So, next up, what is the probability of drawing a heart or a club from a standard deck of cards? One of the things I really dislike about this kind of these questions is that I really dislike statistics. I shouldn't be saying that, but I do. And it's because so much of the stuff we're doing here doesn't have anything to do with the math. Like, this question involved your understanding of dice, which has nothing to do with math. This question involves your understanding of a deck of playing cards, which has nothing to do with math. Prime numbers has nothing to do with this lesson, but we have to know them anyway. So this is like one of the things I don't like. It's not very pure. But anyway, if you guys know about your cards, there are 13 hearts, there are 13 clubs, there are 13 spades, and there are 13 diamonds, which make up the 52 card deck. So if there's 13 hearts, that's a terrible heart. Let's see here. Let's see if I can do a better heart. 13 hearts and 13 clubs. Then there are 26 in total over the 52, but that is also half of the deck, since there are 4 suits and there's even numbers of each suit. Next up, there are 8 books lettered A through H on the shelf. If Scott randomly chose 2 books, what is the probability that he chose books A and B? All right, this question is a little tricky. Let's say that Scott just walks up to the bookshelf and just randomly picks 2 books, right? There's only one set of books that he could pick that would be the correct choice, and it would be book A and B, right? So then you have to ask yourself, what would the total be in this situation? How many different ways can he go and pick those 2 books? This goes back to our previous lesson about permutations and combinations. You have to ask yourself, if Scott goes up and picks 2 out of the 8, this is no different from an example like on the previous lesson where it said that there are, 20 kids in Kyle's kindergarten class and he's picking 6 of them to go to his birthday party. How many different ways can he choose the 6 people to go to his birthday party? Right? In that situation, it was like 20C6, where there were 20 in total, and he's choosing 6, and the order doesn't matter because they're all still going to go to his birthday party. Well, in this case, the order does not matter since he's still picking the books and they're both being selected, right? The books don't care which one was picked first or second. And it doesn't matter to Scott either. So the idea will be that the total number of ways that he can select these books is 8C2. And that so happens to be, pulling out my calculator here. 8C2, 28. All right, moving on. The complement of an event. This is actually far easier than you might seem. All it is that the idea is that the complement of an event is the probability of it not happening. Right? So let me just tell you something, right? Just think about this. If I said the odds of it raining tomorrow is 20%, then you should be able to immediately tell me what the odds of it not raining tomorrow are, right? It's the remaining 80%. And if you're thinking, oh, well, it's the remaining 80%, then that means you must intuitively know that the percents have to add up to be 100%, right? Or they add up to be 1. You converted 1 to a percent, it would be 100%, right? So that is an intuitive thing that you already understand, that percentages have to add up to be 100%. And so if there's only two things that can happen, like in this situation, the probability that it will snow is 7 out of 20 tomorrow. What is the probability that it will not snow? Well, your brain should try to think automatically that it's going to be 13 out of 20. And the reason for that is because it's 1 minus the 7 out of 20. So it's 1 minus the odds that it will snow, which is 13 out of 20. Moving on. A month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? Now, this is the way this is supposed to be taught right now is by looking through all of the months. So we've got January, February, March, April, May, June, July, August, September, October, November, and December. And it wants you to take 1 minus the probability that it does begin with the letter A, which is 1, 2 out of 10. And so that would be, whoops, not out of 10, out of 12. So this would be 10 out of 12. But you can always just count the number of months that don't start with the letter A, and it would be the favorable outcome over the total number of outcomes, right? So you could have done this without even worrying about this 1 minus part. If the spinner to the left is spun, find the probability that it lands on a number that is not prime. We're back to prime numbers again. So looking through the prime numbers, we've got 2, 3. Let's try to make this a little. 2, 3, 5, 7, 11, 13, and that's it. So of this list, find the probability that it lands on a number that is not prime. Well, you can think of this two ways again. It can be 1 minus the probability that it is prime, which would be 1, 2, 3, 4, 5, 6 out of 16. Or you can just count the numbers that are not prime, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of the 16. And in either case, you will end up with 10 out of 16, which can be reduced if you would like. This one can too. Next up, 2 dice are rolled. What's the probability of not getting doubles? Well, let's go back up to this list I made here. If you look at this diagonal, get a different color out. This is the diagonal where the doubles will be. That'd be 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So that would be 6 different choices. There's like 6 different possibilities. 1, 2, 3, 4, 5, 6 out of the total 36. So what's the probability of it not getting doubles? Well, if it's 6 out of 36 to get a double, then it's going to be 1 minus that to not get a double, which is 30 out of 36. Oh, I could have divided by 0. Divided by 6. I'm an idiot. All right, moving on. Compound events. Compound events is the probability of 2 or more simple events. It's called independent when the outcome of one event does not affect the outcome of another event. Like you roll 1 dice, right? And then you roll another dice. The second dice, it doesn't care what the first dice rolled. Those are independent events. Then a dependent event is when the outcome of one event does affect the outcome of the other event. So this is a situation like, say that there's a raffle, right? And your name is in the raffle. And say they're going to say there's 30 raffle tickets inside there, and yours is one of them, right? If they're picking out 4 different tickets, every time that a ticket is pulled, your odds change because there were 30 tickets at the beginning, but then there's only 29, and then there's only 28, and then there's only 27, right? So your odds are changing every event. This would be a dependent event. Now, for independent events, the probability is really easy to calculate. All you do is you just take each of the individual probabilities, like rolling a dice, like 1 out of 6 times 1 out of 6, and you multiply them together. Whereas here, you need to consider each one. Like the first one, you can start by thinking, I had a 1 out of 30 chance to get it for the first drawing of the raffle. And if I wasn't chosen, then now we have to start considering the probabilities given that these events already occurred. So if one ticket was already pulled, then my odds are now 1 in 29. And then if another ticket was pulled, then it'd be 1 in 28. But you see how these are being altered based on the previous instances, the previous events that happened. This would be a dependent event. And so this notation says the probability of A, A and B, which is the probability of A times the probability of B given that A already happened. This is the notation for that. Gotta get a drink of water, hang on. All right. So, next up, independent events. A die is rolled 3 times. What is the probability of getting 1s on each roll? Man, I need to cough. Give me a second to clear my throat. All right. So, what is the probability of getting 1s on each roll? Well, it's going to be a 1 out of 6 to get a 1 the first time, a 1 out of 6 to get a 1 the second time, and a 1 out of 6 to get a 1 the third time. And so, multiply the tops and the bottoms together, and you're going to get 1 over 216. Next up, a coin is tossed, then a day of the week is selected. What is the probability of getting tails, then a day starting with the letter T? See if you guys can do this. These are independent, so you're going to multiply them together, and they don't have any bearing on each other. So think to yourself, what are the odds of getting a tails, and then what's the odds of a letter starting with T? It's a 1 out of 2 chance to get a tails, and then a day starting with the letter T. So you got Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Those are your 7 days of the week. 2 of them start with T, so it's 2 over 7. That reduces into 1 over 7. Next up, getting closer to finishing this. A bag of crayons contains 8 red ones, 14 purple ones, 6 yellow ones, and 4 green ones. Just to add those up right now, 8 plus 14 plus 6 plus 4 is 32. It's going to be important. Here's the gist of it. When you pick a crayon out, you have to put it back in the bag, and then another is selected. This right here, the fact that it is being replaced, means that this is an independent situation, because once you pick one out and put it back in, the odds have reset back to where they were. If you kept the crayon, then this would be a dependent event, like we were talking about with the raffle, but we're putting it back. So that's something to keep in mind. So find the probability that you pick a purple, then you pick a yellow. So the odds of you picking a purple are 14 out of 32. And then the odds of you picking a yellow are 6 out of 32. And you have to multiply those together. And so you're going to end up with 14 times 6, which is 84 over 32 times 32, which is 1024. If you want to reduce that, feel free to. If you want to, maybe we can give a decimal approximation. Be convenient. This is approximately 0.082, so around an 8% chance for that to happen. Next up, What's the probability you pick a green and then a red? Well, a green has got a 4 out of, hey, I wanted to make that green. Hey, a 4 out of 32. And then the probability of selecting a red is 8 out of 32. And so you multiply those together and you get 32 over 1024, which reduces down to 30, or like 1 over 32. But aside from that, I'm going to give a decimal approximation. Hey, this doesn't even need to be approximated. It's an exact decimal. You have a 3.125% chance. Next up, 2 purples. Well, one of the purples was 14 out of 14, or 14 out of 32. And then you put it back in, now you have another 14 out of 32 chance. And so that's going to be 14 times 14, which is 196 over 1024. That's approximately 0.19. Actually, that's not a bad chance. And then 2 yellows. Well, yellow is 6 out of 32 times another 6 out of 32 is equal to 36 out of 1024, which is approximately a 0.035-ish. All right. Make sure you guys are asking questions. Try to absorb this as I'm doing it. You should pause these videos whenever I finish one example if you think you can do the next one, and then see if you get it right whenever I keep talking about it. You need to use this video as a resource, not as like a one constant lecture. So as we do these, you should try to work out the problems ahead of me and then see if you get the right answers. This is an example of dependent events because it's very similar to the situation above, but once you select a crayon, it is not replaced, which means that the odds are going to change as you draw more crayons out. So find the probability of getting a yellow and then a red. So for the first one here, there are 6 yellows and 8 reds. So we've got 6 yellows, 8 reds. So the first time you put your hand in there and you draw it out, the odds of getting a yellow are 6 out of 32. But now there are not 32 crayons in there. There are only 31. But there are still 8 red ones in there. So your odds would be 8 out of 31. And so you take 6 times 8, which is 48. And then you take 32 times 31, which is 992. You have a 48 out of 992, which is approximately a 0.048 chance. It's like around a 4.8%. See if you can do the next ones. All right, these next 3 you should be able to do right now. So pause it, see if you can do them. Well, there are 14 purple ones. And there are 4 green ones. And so the odds of getting a purple one first are 14 out of 32. Then the odds of getting a green one are 4 out of 31 because you had to pull the purple one out. And then now your odds have gone up a little bit. And so you've got 14 times 4, which is 56. And then over your 992. I'm just going to leave it like that. If you want to put it as a decimal, feel free. 2 red ones. Well, all right. So the idea is that on the first one, you have to imagine what the probability of getting a red one is. So it'd be 8 out of 32. And for the second one, you have to imagine that you already got 1 red one out. So what's the odds that the second one is also red? Well, there's no longer 8 red ones, there's 7. And there's not 32 crayons anymore, there's 31. So this is what you've got. Next up, 2 green ones. There's 4 greens to begin with. And then after you take one out, now there's only 3 of them out of the 31. Pretty low chances here. Last 2 questions. A card is drawn from a standard deck, not replaced, and another is drawn. What's the probability of choosing a heart and then a spade? Well, there are 13 hearts out of the 52. But now since you didn't replace it, there are only 51 cards, but there are still 13 spades. We had 13 hearts out of the 52 in total. And then there were 13 spades. I'm coloring them red and black because that's the colors of the cards. Now, Jack had 4 Snickers bars. Dang, he's lucky. And 8 Mars bars. I don't know if I've ever had a Mars bar in my whole life. Have you had a Mars bar? I don't even know what kind of candy bar it is. I think it's chocolate, though. He randomly chose a piece of candy, ate it, and then chose another. What's the probability that both of them were Snickers? Well, he was sitting pretty if he had 2 Snickers. So the probability of the first one being a Snickers is 4 out of the 12 because he's got 12 candy bars in total. But then he didn't have 4 Snickers anymore, and now he only has 3 out of the 11 remaining candy bars that he has. So this is going to reduce into like, what is it, like 1 over 11? Yeah. All right. This is an 11, by the way, down here. That wraps us up. You guys should have all of the information you need to do your problems now. The hardest these questions get is when we're dealing with stuff like this one here, where you need to use a combination to determine the total number of the total number of outcomes for Scott here. So that's the only time this is going to get tricky. Other than that, it's just going to be your knowledge of random other nonsense, cards and dice and months and days and that kind of thing. If you don't know, if you're not very knowledgeable about that, just ask and I'd be happy to help you. Anyway, hope you guys enjoyed it, and I'll catch you on the next one.